background of the study. SQS established in 2000 under the name of Faculty of Quantity Science. The faculty is rebranded to School of Quantity Science in 2010, in under the UNM College of Arts and Science. 3 courses offered in SQS. There are Business Mathematics, Decision Science, and Industrial Statistics. Decision Science have 5 components. The components are University Course, Core Program, Minor, Elective Program, and Free Elective. Decision Science students are compulsory to take 20 subjects, including practicum in Core Program. Core Program have 69 credit hours. Problem statement. We have 3 problem statements in our research. Firstly, students will more attract to study with lecturer that will catch their attention. For example, lecturer that have good personality or good looking or generous. The student will more attract to the lecturer with have good personalities. Secondly is students have high tendency to attend the class with the lecturer that in the past had taught them. This is because they have past experience with lecturer and already familiar with the lecturer teaching method. For this reason, they will more comfortable to study with the lecturer that already teach them. They know how the lecturer teaching method. And lastly, some senior or friend that may be suggested learning with lecturer that had taught them. The student will ask their opinion to their friends that already taken the subject or to the senior about how the lecturer teaching method. So the seniors or their friends will advise them to choose the lecturer that have good teaching method. Research question and research objective. 3 research question and 3 research objective. Firstly, why identify student preference of lecturer? We identify student preference of lecturer to the certain subject. Secondly is how to assign lecturer to the subject. Assign lecturer to the subject by using student preference. And lastly, what can be optimized to the lecturer? Optimize and enhance the lecturer subject allocation. Scope of the research. Our scope is the study is conducted among the SQS students who have taken the core program subject, especially the subject that has been selected such as computer-aided data modeling and database programming in business, quantitative and science technique 1, quantitative science technique 2, data exploratory and computer modeling. The scope also includes the lecturer of SQS in Decision Science department that teach the selected subject that has been listed.
For the literature review, the selected literature review is assignment problem is flexible combinatorial optimization problem occurs in various situations such as timetabling problem and allocation problem, which is a real-world problem. Barron and Skill stated the course scheduling and assignment of student problem is related to the student preference for the course that is proposed. A study by Ongi, the university and the faculty assignment problem is a process of assigning faculty members to teach specific section of particular courses each semester. The objective of this research is to maximize the total evaluation rating, where assigning those who has the highest competency to teach that specific subject over the others. To analyze the problem, we use Excel solver to get the maximum preference of the student to the lecturer and course. Here is the table of the credit hour for the lecturer and subject, where we have lecturer A, QS, and 7 subject, which is computer-aided, data modeling, quantitative science technique 1, quantitative science technique 2, programming in business, computer modeling, and heuristic. From this table, we use solver by setting the constraint where our objective is here, and the changing variable is the table. Below here. By setting the constraint where each lecturer has the minimum slot, minimum credit hour of 3, and for each subject has 1 slot that need to be fulfilled. After solving, this is what we get from the constraint. For our third constraint and fourth constraint, we stay using the same table, but for the constraint, the third constraint is the maximum credit hour for the lecturer is 9, and the maximum for each slot of the subject is 2. And from here, we solve it, and this is the recommended constraint, or the optimum constraint that we can compare with the preference score. After we obtain the preferable table of the constraint, we compare it with the preference score table, where we want to get the maximum preference of the student on the lecturer to course subject. We use the same methods as before by using solver, where the constraint for each lecturer is 9, and for each slot of subject is 2. And from here we can see that, and the result shows that for lecturer A, the lecturer A is suitable to teach subject heuristic, and for lecturer B, it is suitable to teach computer modeling, and also lecturer F, which also suitable to teach computer modeling. For lecturer K, there are 3 subjects that is suitable for the lecturer to teach, which is quantitative science technique 1, quantitative science technique 2, and heuristic. And for lecturer M, quantitative science technique 2. For lecturer O is computer aided data modeling database, programming in business, and for lecturer Q, data modeling and database, and also programming in business. And the last one is lecturer S, which is quantitative science technique 1. However, for this model, we can see that not all lecturers fulfilled for this. As we can see here, not all the lecturers fulfill the recommended credit hour, where each lecturer need to teach at least 1 subject. And from here, we need to create a scenario where we improve the slot for each subject. As we can see from the previous model, we know that not all the lecturers fulfill the criteria that each of them need to teach at least 1 subject or fulfill the credit of 3 hours. Hence, we created a scenario where we maximize the slot for each subject to 4 by using the same method using solver. This is our constraint. After solving it, this is our result. As we can see here, all the lecturers fulfill the criteria, and for lecturer A is data modeling and database and heuristic. For lecturer B, computer modeling, C, computer aided, D and E, programming in business, F, which has two subjects, quantitative science technique 1 and computer modeling. G, H is computer aided. I, quantitative science technique 1 and J is quantitative science technique 2. K teaches three subjects, which is quantitative science technique 1, technique 2 and heuristic. For lecturer L, computer modeling. For lecturer M, quantitative science technique 2. For lecturer N, heuristic. Lecturer O, computer aided and data modeling and database, and also programming in business. For lecturer P and Q, data modeling and database, and programming in business. Lecturer R, computer modeling, and lecturer S, quantitative science technique 1 and quantitative science technique 2. After comparing this table with the preference table that we have here, we can see that it is fulfill the objective, which is maximizing the total preference of the student on the lecturer to the subject.
Conclusion and recommendation. Firstly, assignment problem is suitable for problem search, timetabling, and allocation. Based on the result that has been discussed, the lecturer is assigned to the subject based on the student preference. The result also can be improved after adding scenario to find a better solution. For future study, the consideration of lecturer choice and the faculty can be used in order to be certified and give more optimal solution for the research.